Yeah, I mean, the clear benefit of single flight mutations is that almost every interaction that you have that involves going to the server now happens in one jump rather than two. The latency going between the server and the client can be significant. Sure, going to the database is maybe 40 milliseconds, but going server client round trip is usually at least 200. So you've taken things that are commonly now, 2 hops, so maybe 400 milliseconds, and now they're 200 milliseconds. Every interaction on the page has doubled in speed.
That's fast.
You don't have to obviously use this kind of cache revalidate approach, but modern web has almost completely gone that way because of the DX aspect. This way you get to have the DX you enjoy from TanStack query or similar, but the performance you get from server components.
Hello, everyone, and welcome to another episode of Modern Web Podcast. I'm your host today, Director of Technology at This.Labs, Danny Thompson, and I'm joined with Ryan Carniato, creator of SolidJS. Ryan, thank you so much for hanging out with me today.
Thank you for having me. I'm really happy to be here.
Honestly, I'm a big SolidJS fan. I'm a big Ryan Carniato fan, but I kind of been watching a lot of your stuff recently, and I kind of came to some questions based off of that I think will be really valuable. But I was watching one of your talks at VConf, which honestly really great talk, but I came up with this question because I've been hearing so many different interpretations of server-side rendering and what people have, and referencing a quote that I'm now using quite often from Tanner Lindsley: every framework will have their own interpretation of what that looks like for them. So I kind of wanted to see what your opinion was on this, and can you elaborate on the limitations of previous attempts to bridge client and server, such as PHP and Rails, in the context of modern JavaScript development?
Yeah, that's a big question. There's a lot of history here, obviously. It's an interesting, we have an interesting challenge, I think, in the web, in that obviously innately a client and server model, right? Every site starts from a server somewhere. But on the other hand, the language that we use in the browser, JavaScript, was primarily for the browser, and other languages don't exist there. So it's always been kind of a bit of a challenge to figure out how to approach that, right? Initially, the easiest thing you can do is just build a bunch of pages on the server and render them and get pretty good experience there. But obviously over time, we want more interactivity, right? And as JavaScript increased, well, we saw that there's a lot of duplication between code and logic. And it was one of these challenges that made it really hard to maintain apps. You almost had like 2 different apps sitting on the same page next to each other. And it was very awkward because there'd be a lot of overlap. Like if you want to, say, render a list of things on the server and then manipulate that in the client, well, it's pretty awkward if these 2 places can't sit on top of each other. Like, because something becomes interactive doesn't mean you shouldn't server render it anymore. And honestly, this feels so fundamental to the web these days that we really, have to look at this through, different eyes. I think we've tried lots of things. We've tried doing everything on the server, basically. We've tried to do everything on the client. That had its own challenges, right? Single page apps. Over time, they just got bigger and bigger, and logic, more involved. And one of the consequences there is that we gave up our initial page load. It wasn't good for maybe apps, but not for, say, e-commerce sites or things that relied on SEO or, quick loading speeds. I actually worked at eBay for a number of years, and page load was incredibly important for them because bounce rates, you're on a Google search. It's not just like the SEO data for rankings. It's like if you click a link from a search because you see a product, if that page doesn't load within 3 seconds, a large chunk of users just bounce. And they have stats to kind of show this, right? And different, regions around the world have this consideration in terms of like different latency and different, average device power and stuff. There's a whole area on this. So like, it's important to kind of acknowledge that both sides of the problem are, both the client and the server are fundamental pieces in this, right? You can't just say go all one way or the other way. And we've been over time figuring how to merge it. And a lot of cases in the JavaScript world, its power being that it has this one language that runs on the client and the server allows us to have single development models. You can build an app once essentially and have it work on both sides. But even with that, while that made developer experience good, it alone has not necessarily solved the problems of being too client heavy, or basically we're still shifting the pieces to kind of see if there is an ideal fit, and there might not be for every single type of app. Like each type of app might have their own weighting. If you're making a content heavy site, something you might use Astro for. Maybe you don't need to have all this JavaScript. You don't care, that much about, certain aspects of, interactivity. You can, if the page loads fast, you don't care about, how much crazy, complexity is happening in the JavaScript level. But on the other hand, you have other apps that are basically, could be a mobile app, basically built into your web app browser there. And in those cases, you need all that interactivity. You can't take those, you can't wait on the server. You can't do these full page reloads. And I don't know. I think as frameworks get more general purpose, there's this desire to see if we can bridge it. When someone goes, I'm building something for the web, it's been difficult to say, oh, just use this tool, because basically it's like, oh no, if you're doing this, you have to do this. And if you do this, you do this. And if this, you do this. It seems very odd to have multiple different, not just like technologies you might use, but like architectures. But the truth of the matter is, we haven't completely solved this. So the thing that, getting back to your question, the thing that is actually, different this time than say Ruby or PHP is that we have gone full circle. We are looking at server first primarily, but from a language that actually runs in the client. And I think this opens up potential that we have not basically seen yet. This is new, even though it feels like it's old. There are differences here. As I mentioned, being able to run the code on both sides, being able to own the same section of the UI. See, like there's two factors here. Not to get too technical, but it's like, if it's the declarativeness of our frameworks, basically. Most frameworks now are based around having declarative templates. You basically own a section of the page. So it's difficult to have multiple tools own the same section of the page. And it's funny now saying this, but it was really a reality back in like 2010 or whatever. I remember putting Knockout on top of ERB templates. And I'm seeing it a little bit these days when people are using stuff like HTMX and layering it with, React or whatever. Like it can work, but at a certain scale of complexity, it's hard to keep in your head, like I'm iterating over the list here and here. Like it was a really funny kind of code where you basically, if you rendered that list on the server and then you have to update the list on the client, well, guess what, Now, I think technology has come a long way in the last 10, 15 years as people have, explored these areas. All these approaches have evolved over time. But the piece that seems constant, even though they're very different architectures, is that people are looking for that, possibility that could be one tool to rule them all.
Do you think that, and I say this because even at the beginning, you were saying, everyone's been trying to solve this problem and now we've come full circle. Do you think that we're on the cusp of actually getting it right? And if so, what does right look like to you in this context?
Yeah, I mean, this has been the challenge. It's are we close? I keep on feeling like it's just beyond our fingertips, but every problem kind of unveils something new, some kind of more profound understanding of the fundamental situation, for me at least. Like I looked at things like React server components and Astro islands, and I've looked at things like resumability. Marco was implementing it at eBay while I was there, Quick framework. And, and I've also looked at these HTML partial solutions as well. They're actually, all these solutions from my mind are all part of a spectrum. But what's interesting is trying to step back and going, okay, these are novel approaches. Do they actually impact like the technical reasons for why we are exploring beyond? Like at a baseline, you could say that single page apps with server-side rendering do the full thing, right? There's hydration errors and stuff that happens. There's going to be challenges like that regardless when you basically take a system on one platform, run it, and then pick it up, move it to another platform and run it again. But, I'm talking about running on the server than running on the browser. But those things aside, you could say that we already have a baseline. But we want to do better. And the reason we want to do better is sometimes when you take two things and you push them together, you end up with just the worst of both worlds, essentially. Like you might get the best of both worlds, but you might also get like, you're now paying the price twice or in two different places. And that's why it's really taken architectural level thinking. Like the thing is, as of today, this might change. I've been looking at this a couple of years. I have ideas how individual architectures could address those kind of shortcomings. The thing that, would fundamentally go, okay, this solves it and it actually improves things. But the funny scenario is where I sit today, most solutions, even though they're drastically different in terms of the way they mechanically work, are actually getting stuck by the same types of problems. And they actually aren't quite there yet in terms of actually accomplishing the goals that we set out to do, from my opinion.
Could you maybe elaborate on what you think some of those problems are?
Well, the biggest problem with single page app type architectures is that that page load time. Like they're pretty efficient after the fact, but you have all that JavaScript. You have that, the hydration time on the server rendering. And you also have all this data serialization to support that hydration. Basically, you send a bunch of HTML, you send a bunch of JSON, like your data, and you send a bunch of JavaScript to process that data and then match it up with the HTML so that from that step forward, everything works as if it had been rendered in the client in the first place. And the thing about that is there's lots of JavaScript, which may or may not need to be there. Its size is largely governed in most frameworks by actually the size of your UI, like the number of components or the number of HTML elements, not on the amount of interactivity, but the amount of actually like how big the UI is in terms of elements. And then the other part is often that data that you send down is a duplicate of what you rendered in the HTML. You basically send all the data serialized as HTML and serialized as this JSON. You've seen it if you've used Next or Start or SvelteKit or Nuxt or whatever. There's like a like Next data blob on your page of this JSON. So you're serializing it twice. So you have larger payloads than if you just like didn't hydrate, larger JavaScript. So you on one side you have these sites that are basically static HTML, maybe like a tiny bit of JavaScript, and then on this other side you have this solution which basically just sends everything over the wire. So we have to look at how we can solve the JavaScript that gets sent, the JavaScript that gets executed, and the amount of data we serialize. Those are the things that can go away, right? We can't get rid of the HTML. We need to be able to see the HTML. Obviously, we can't get rid of all JavaScript if there's interactivity, but we have to look at the size of that JavaScript, and we have to critically look at how much of that JavaScript executes. And with a single page single page app mentality, you end up in this world where there's this expectation that it's a single app and everything runs. So you don't get the cut down on JavaScript execution. You don't get the cut down on the JavaScript that's sent, and you don't get the cut down on that data. And those three criteria are how I look at how successful these solutions are at achieving the goal, because you want to have the experience after first page load of a single page app for the most part. Like it, but you want the loading characteristics of something that's perhaps more efficient, and as a developer, you want being able to author this to be straightforward, like doable in a single way. So we've got these 3 points, and it sometimes feels like the cost triangle, where you like can only get 2 out of 3. That's the game. The last couple of years, it feels like what I've kind of come down to as a sort of conclusion is to get the experience that we expect out of single page apps. Most solutions have found ways to cut down JavaScript execution and potentially even cut down JavaScript size. But data serialization is actually as ever prevalent. And pages with large amounts of data, it is actually the largest impactor on that initial page load. So in a sense, as I was doing my research, I found that like for the most part, we might be getting nicer DX or something that more aligns, in the server model. But we were basically resulting in apps, if done optimally in each of the different architectures, actually producing the same results. Basically being like, okay, maybe one sends a bit more JavaScript, but not in a way that's necessarily impactful. Maybe one runs a slightly less JavaScript here or so, but that data serialization was the same or similar enough that it was that constant. And it meant, from my perspective, that maybe that's not something we can solve, but it means that the impact perhaps of these new technologies versus server rendered single page apps might not be as big as we were making them out to be. Like maybe server components actually don't improve page load performance compared to a single page app written in a smaller, faster, more efficient technology. So yeah, it really got me to thinking, because honestly, after spending so much time looking into these topics, I needed to find some kind of concrete metrics to go by. That's how I've always built with Solid. Solid was originally built from benchmarks. I basically worked through tons of different benchmarks and looked at approaches and saw what they're measuring to understand what the ideal architecture could be. And then I worked from there to build what made sense with it. But I started from the benchmarks. I started from the performance, because for me, yes, there's that, build, make it, I never remember this saying, because because I generally don't follow it, but it's like, make it work, make it right, make it fast. Yeah. There's like that 3 phrase. That's not the order I do things. I do make it fast first, because in my world, if make it fast isn't viable, then the whole thing probably should just get thrown out anyways. You're wasting the rest of the time, and that's kind of what I'm looking at. Like it's not too hard to kind of like come up with solutions and go, we'll optimize that over time. But the reality is we usually don't. So it's important for me to understand mechanically what we should be doing. And while this can lead down to deep rabbit holes, sometimes you just look at the state of things and go, you know what? I'm not wasting any more time on that. I'm going to see if there's other options.
Let's take a pause from the conversation real fast to say this episode is proudly sponsored by This.Labs, your partner in modern web development and consulting. At This.Labs, we specialize in empowering businesses to reach their full potential through technology. We understand that in today's fast-paced tech environment, adaptability and efficiency are crucial. That's why we offer tailored solutions designed to meet your unique challenges and objectives, and our commitment to excellence and client success sets us apart as a true advisor in the industry. Discover how This.Labs can transform your business. Visit this.co to learn more about our services and how we can help you stay ahead in the competitive landscape. Now let's get back to the episode with Ryan Carniato. Yeah, I can even echo that from my own personal experiences. I think every organization I've ever worked at, it was just get it out there quickly. We'll refactor, make it better later. Later never comes, and you're just bogged down with tech debt with the hope that we finally improve this thing. Then maybe you get like a random sprint 0 where you can finally improve it. But this kind of made me start thinking about one thing, and maybe we can answer this, because you're right. That's one thing that I've kind of noticed about you. There's a lot of emphasis on improvement and making things performant, and it kind of brought me to this: like, how did the routerless approach in SolidJS contribute to its small bundle size, but also from the aspect of flexibility?
Yeah. This is an interesting one, because this actually came from like a different place. For me, it was that, how should I put it? I was struggling with this narrative that's been happening recently, where, React core team members, who ended up moving to Vercel anyway, but basically they were like, don't use React on its own. If you use React, you should use a meta framework. This all started up after there was that whole like create React app was clearly aging, and then like essentially, I think it was Theo. He went and he's like, let's change the starter to Vite, and they're like, no, we don't want to just replace create React app with another create React app, so to speak. Let me make this clear: Vite is not a create React app by any means. It's much more flexible. You don't have to eject. It's much more capable than that. But they were like, let's embrace with the ecosystem. The big part was as they started building React out more to, be kind of almost like a spec, like where there's like a whole bunch of these moving parts. It's almost like pieces you need to build a framework. They were like, you can't really use it without actually having said framework. So they're like, you should use Next, or you should use Remix or whatnot. And to be fair, honestly, I shouldn't say to be fair, but just honestly, from my opinion, this horrified me. What I've always liked about React was the fact that it wasn't so uniform, like that people complain like, oh, I it's not like Angular where you have all the pieces and the services and you're like, oh, I can just go and use this. React has this, mess of an ecosystem and, makes it harder and all this stuff. That is the best part of React. And
yes, sorry, I'm enthusiastic about this topic.
And I was sitting there and I was like, I think it's good for people to have opinions. But I've got to be careful how prescriptive I am at the framework side. There's always that kind of split. To be clear also from what I said a little bit previously, when I talk about that make fast, make right, make, correct or whatever thing, I think people do it the right way when they're building applications. Like, I think it is important to get bottom line to get the product out. But as a framework author, I'm in a unique place where I can focus on the areas that you don't get to focus on. So that's why we should look at stuff kind of the other way. And for that reason, similarly, when looking at meta frameworks, I was like, I don't want to be too prescriptive. I don't want to say like, you have to use this. While on one hand, that's a good way to get adoption, other people will do that. Other people will come in and go, this is the hot thing of the week or year. I wanted to make those tools. And it's the same philosophy that React followed through, all its early years as it grew. Obviously, because of the saturation in the market now in terms of like framework choice, this isn't always the best thing. As I said, sometimes giving targeted solutions is good, but it just doesn't sit well with me. And when I was looking at Solid Start and looking at what I wanted to accomplish, I didn't want to come off with, forcing people down this line. If things change in a couple of years, because they tend to, I wanted to leave that door open. And more so, I wanted to be able to have the room to leverage the libraries already in the ecosystem. So it's important to me because any router, is a very fundamental piece to JavaScript framework. In fact, I've often said that router is actually fundamental to the web in general. Every major shift in web technology architecture has been around a change in routing. And it makes sense because the web is a router, right? Like the multi-page app, classic web application is all about a URL. Like the whole app is the router. When the technology that led to single page apps establishing, largely you could argue was around, being able to handle things like push state properly in the browser. Like there's a technology advance around routing that fundamentally enables these technologies. Sorry, push state is what technically enabled SSR. Technically, hash routing is what enabled single page apps, but push state is so that you could have the same URL on the client and the server when you like refresh the page. But the same thing kind of holds here. So for me, who knows? A browser builds in a navigation API or something. I want to keep it open. But on the other hand, there's a lot of tension. Is server components going to be the future, or that kind of architecture or different kind of architecture? It's important to be able to like recognize where the split is. And that was very key. It was something I wanted to do from solid start from the beginning, but we didn't quite figure out where the boundaries were. And then when I was working with Nikhil, and he built this library Vinci, which is kind of the basis now of solid start, we saw that the application router and the file system router could be separate. One could be the file system router could just be a plugin into the configuration of the application router, and then the application router is only one of the actual targets. The other thing the file system router could be is a target into the asset management. The biggest reason frameworks have file system routers is because they have to manage assets and code splitting and stuff. They want to be aware of like, okay, these pages load this CSS and are associated with this route so that they can do smart things. So as long as we basically had some kind of generic data that we could basically take out of the compile time to know that information, we could then feed it back into the runtime and in theory support any sort of router regardless of, what other technology it needed. And that was key to me. There's a few little pieces with the file system routing that were important. Like we made a generic config export for every single route. So you do like export default, which is like the component. Every route has a entry point, but then we'd have a config if you export a route constant, and that config, you just type it the way your router configs its routes, and then you basically can add any additional properties to the file system routing based on the router of your choice. So like this way you could just swap the router. I'm very aware of stuff like TanStack router. I'm aware of stuff going on in the shared ecosystem. We should, if someone wants to use that kind of technology with Solid, they should. And solid start shouldn't be like, like we didn't want to repeat it. The React situation was like, okay, no, now you have next app directory. You don't get to use TanStack router. Or now you have Remix, which is React router basically. They've kind of gotten to that same point, but now you don't get to use this one. I was sitting there just going, look, I'm really happy with the work we've done with the router. Sure, I am an author of Solid's router, but that shouldn't stop someone else using their own router. And I realized the less things that I pulled into Solid Start, the more it encouraged the ecosystem itself to grow. Like if you want to make metadata libraries and stuff. And this makes it less of a polished project, so to speak, from a perspective of like, here's everything built in. We've gotten to a point in React land that we've already seen the impact of getting opinionated, like things like Create T3 app or Redwood. These frameworks basically could just be that opinionated layer, and often are. Like Create T3 app is just Next.js with these added opinions. I left it open to the community to kind of come up with that because like what was it, TRPC, great technology. Maybe it's what's really good now. Maybe in a couple of years, no one's going to use it. I don't know. All these server functions and stuff floating around. But the key is like, if we don't build that in, someone will put a library that uses TRPC. We have something, create, JD app, which is a Create T3 app, but made for Solid Start, essentially, which took Prisma and all the opinionated stuff on Solid Start, and there you can go. We also have Solid. I think it's going through a rename. It's called Media Kit. It might be called Start Kit soon, which again is a wrapper which brings in more opinionated things and stuff like image processing and all these pieces. Like there's just if I don't make those decisions and opinions too hard out front, it means that others can take it past where we reasonably can. And this is important for us as an open source team, that actually doesn't have that many, maintainers, so to speak. We have lots of volunteers, people contributing, but when I look at the scope of the project, I want to keep it within a manageable range. So this kind of gives people the pieces they need to succeed, right? You don't want to not give them that. You can't just be like server-side rendering, go figure it out yourself. That doesn't really work. But we also don't have to be like, here, use the meta framework. It's more of like, let's start that meta framework, basically shipping nothing. It's basically a starter kit. That's why I called it Start. I was thinking like, because it is, the bare template is less than 5 kilobytes of JavaScript. Like the example, that's what compiles down to minified and gzipped. It's as small as the Vite starter. It's basically smaller than most things, and that's maybe not what you end up with. We have more advanced templates and other situations and these things built around, but it is a baseline that anything can use.
You've mentioned a lot. This is a subject I'm very big on, to be completely honest with you. And that was kind of the appeal when I first came to React, where if you would have said React were a framework in like 2021, 2022, the whole world would come after you. Be like, no, it's a library. And it was that whole aspect, especially me coming from Angular to React. It was this whole openness of you get to choose what you want. You get to utilize whatever you, as you've said it best. I've never heard it mentioned that way, but I love that phrasing. Opinions on what you want inside your application. But now we're starting to hit this area where it feels like every tool is starting to do some form of vendor lock-in, to where they want to be the solution. They want you to encompass all of their ecosystem. And do we see this going forward? Like majority of tooling saying your opinions are no longer completely flexible. Sure, you can have something here. And if that's the case, are we just now approaching to the time where React will become now the framework de facto for React.js? And I guess because now most people are saying, well, I don't use React, I use Next.js, right? Or they're now saying, if you looked on resumes before, say I code with React.js, now it's Next.js. So it's like, from that standpoint, do we see that becoming a bigger feature?
Yes and no. Next is a funny anomaly in that they have a framework built by a company that uses React, that employs former React core, I guess they're still React core team members, that enabled them to build out their vision of how this could work, with server components and stuff. So like, how do you build a framework at a company that does hosting and not build towards the infrastructure that you have to maximize it? It's basically like, it makes 100% sense from a business standpoint, from a technology, all the things are aligned. You should go do that. The challenge obviously then is like, now suddenly it doesn't deploy the same on other platforms, right? It's not a secret that platforms like Netlify or Cloudflare have put considerable effort to try and make Next work, because a lot of those features are tied into the platform. Like stuff around like SKU protection in terms of like being able to support multiple different builds in out there in the world. Things like server components need server-side caches. It's fundamental to the architecture if you want any kind of performance. Client-side apps didn't need those caches. Yes, you would probably cache some heavily hit stuff, use Redis or something. But as an architecture, server components need server caches, just straight line. Where in the client, you just like keep something in the browser and not refetch it if you didn't need it. It's kind of like the 10-step query mentality. Server components need caches. Suddenly you need some kind of persistent storage on the infrastructure. So like, this is unavoidable, right? Whether it's Blob on Vercel or other platforms have similar offerings, but it basically sets that baseline from an infrastructure standpoint, which allows them to try to do interesting things like PPR, partial pre-rendering, which again, takes some doing on these other platforms to cater, like Next basically has to show the way, Vercel has to make it possible, and then others will follow if they make sense to. So there is that aspect of it, definitely. Interestingly enough, most other frameworks aren't like that, but they're also not incentivized to be that way. First of all, they're not the most popular. It's always the most popular that gets the most benefit from lock-in kind of scenarios. And secondly, like, because they're not aligned with this particular company, often they, especially on the hosting side, they just want anyone to be able to use their stuff. So like, I don't know. I think ultimately there will be a push, like as good as R&D is when you have that alignment, there's always going to be situations where people ultimately will want that flexibility. I don't think the lock-in, like either, over time Next will get solutions in other places, that fill, or people will not like the lock-in and choose other options. Like I don't think this is a permanent state. I don't think it has to be a permanent state. It is helping us understand what the baseline is for infrastructure, what the pieces are. So there's a lot of value in that exploration, but I'm not terribly worried about the lock-in. I mean, if you choose to use Next.js, I guess you are kind of making that decision knowing like the fate of Next is in the same hands as the people who build Vercel. You understand that. But beyond that, I don't think this is a general trend.
So about, I think it was a month and a half ago, I saw you share a really good demo of someone who made like a clone of Trello. And I thought it was like a really cool demo. I saw how you were going through things. And one thing that you kept emphasizing was a big reason why it was so performant, even through all the edge cases that you were throwing at it, was one big significant benefit was the single flight mutations. So for me, I want to ask from your perspective, what are the specific or maybe even significant benefits of single flight mutations in terms of like user experience, performance, maybe things people should know about it?
Yeah. This is a technology that not many people have heard about, probably because I dubbed the term and then didn't really write too much about it. But it's starting to have impact further out in the ecosystem. Again, this was a result of some of my research. I was sitting there and I was going, with that baseline that we weren't solving data serialization with server components or with resumability, what are the benefits of using some of these other technologies? And one of the benefits for server components is that they work like MPAs almost. Like when you're on a website, and let's say you're like filling out some details, like you're writing a post or something. I'm thinking like an old website here. Mostly like a scenario where you like go to a special details page and fill out the config, and then you hit submit and it redirects you back to the list, like a CRUD kind of setup. If you do that in an old, Rails app, or even in server component land, what will happen is you'll post your form and then the server will essentially respond with the next page. Like you post and within the same cycle, you get back the list page. Right, that's how server actions work. You post on the page, add the new item, get redirected to the page with all the items, and basically, even on the same page, like it's kind of obvious that single page apps don't do that. Single page apps will generally post the JSON, do the update, return like a success message, and then the client router will route to the next page, and then it'll go fetch the data for the next page to render it. But what I was going to say is even on a single page mutation, like, so you're on a long listing, like a Hacker News or whatever, and you're writing a comment at the bottom. In those scenarios, single page apps often still submit the comment and then refresh the data again and not send it back. You could patch it, but a lot of us don't. And the reason is developer simplicity. Things like TAN-stack query are so popular because you just say invalidate this cache key and it'll refetch. But when you do a mutation that invalidates a cache key, you are actually saying update the to-do list and then go get me the to-dos. It's two operations. And we got kind of complacent this way because back in the day, we would just say, add a to-do and then get that to-do back and then insert it ourselves. But as UI got more complicated, you're like, oh, what if the thing's in like 6 places in the UI? You didn't want to like update it in 6 places. And then they were like, okay, well, you can make your own cache. So then you'd write to the cache yourself. This is highlighted probably at the peak of like GraphQL. GraphQL was like the pinnacle of making sure the client did really optimal stuff. But if you've ever, used Apollo with its normalized cache, you're like 40 kilobytes deep in JavaScript. Like it's as big as React, like just to get that alone on the page. So it's a heavy dependency, and you're like quite often still manually managing caches through pagination. I've been there. No one likes doing that. So the simpler solution was just revalidate it. Don't worry about it. And Remix, for example, ended up doubling down on that, right, with their actions and loaders. Because again, they're just like, let's not deal with caches on the client conceptually. Let's just revalidate. Action triggers loader. And they had a really smart way of solving this with optimistic UIs, because most solutions to date before Remix with optimistic UIs would involve writing to the cache and then rolling back the cache. Again, more cache operations that are really, prone to bugs and hard to write. So they're like, what if we just took that state and feed it back into the React tree and then be able to render it. And then when the action's over, just that state goes away and the UI updates. So no cache writing. And once it was kind of shown that you could basically remove the cache conceptually, in terms of writing to it, not in terms of keys, but in terms of writing to it, I think it became very attractive for people from a DX standpoint to basically, every time they change something, do 2 requests. Basically, post the change, refetch the specific data that updated. And it bugged me because this is the one place that server components actually benefited, because they could, go back to the server and return the next data and have it all, use the React's renderer on the server to make sure that like everything's consolidated back in. So I was like, can we solve this without server components, right? Because there's lots of discussions about waterfalls and data fetching waterfalls and all this kind of stuff. And for the most part, client-side apps have solved that through loaders or like hoisting the data fetching into the router. But Mutations, every request was 2. It was just double. And as it turns out, I realized that we could. And the solution to that involved 2 things. It involved keeping that cache key mentality, but using it with server functions. So I know React is actually going this way, ironically, but when they introduced server functions, there was only server actions. They didn't just think of it in a generic way. Well, when we introduced server functions before them, actually, we did it as just purely transparent functions. We didn't care about, there's no routing semantics to them. They were just functions that ran always on the server. If you're on the server, then they just run as an async function. If they're in the client, they run as an RPC call. But if you combine that, at the time you do the action on the server, you know what you're invalidating, you know what keys. And in fact, I'd go as far as if depending on the response, you actually know the routing, if you're doing a redirect, all this information. So all we had to do was take the keys that invalidated, or, all if none are provided, take that routing redirect information and send back the response with the promise of the next data. So we use the same loaders or preload part of the router that we used to hoist. We rerun that on the server at the end of the action without rendering out the whole app. We just basically fetch the data and based on the keys, choose, actually only fetch this data. And we serialize it as a promise. And then since our serializer, Serial, supports serializing promises, we could just send back the response as soon as the action is done to tell the client, hey, you're going to route to the next page, or you're reloading the current page. But at the same time, seed the client-side cache with those promises so that as they completed all over the same stream, they update in place. So we get this benefit of not going back and forth twice, halving the latency essentially in a normal single page app situation. I mean, in fact, this technology works even with SSR turned off. You obviously need a server for it and something's processing server functions, but generally speaking, it is a purely client-side mechanism that just happens to play with data serialization. This is why I love server functions, honestly. It was the same mentality again. I designed them the way we did so that they could fit into any existing client-side API. Again, I don't want people to have to write new versions of libraries. I want someone to go, oh, TanStack query. Oh, this data here is in a database. It's not from an API endpoint. Use server it. Like that's the kind of mentality here. You could just, whether it's fetch, whether it's post, it just fits into the same mentality. It's a function. So guess what? TanStack query accepts an async function to fetch. Well, guess what? That can be a server function and, query the database directly. I know that's a long-winded response, but essentially realizing using the information that we basically already had with controlling serialization on both sides, we could basically optimize between the route kind of hoisted loaders and this kind of key-based invalidation. This very effective way of doing the data reloading. And what's really, really effective or cool about it is it doesn't, unlike server components, it doesn't need that server-side cache I was talking about, like the blob storage, because it doesn't re-render the whole page. And because the keys tell it exactly what invalidates, it's just like on the client. It only fetches the things that need to be fetched. So if you have like 6 different data sources on the page, because we know, oh, this action invalidates to-dos, it only fetches the new to-dos. It doesn't fetch the other 5 sources. Whereas classically with something like server components, you would re-render, that part of the page, and then you'd hit those 6 sources, and they'd all be cached using like blob storage or some kind of infrastructure piece. And then you go, okay, I'm invalidating this one, and you refetch it. So in the end, the same amount of work happens. The only difference is there's no backend infrastructure needed outside of like the actual like web server to support this. You don't need any external storage.
Yeah, Ryan, I mean, it's pretty incredible. I guess my question now is, what are you working on now? What do you see coming out soon for you, or something that you're really putting a lot of effort into right now?
Yeah, gears have shifted now that SolidStart is out. I'm very happy that people can use this technology. But yes, this is what I was working on, almost a year ago, 9 months ago. So my focus has gone back to fundamentals again. Now that I'm happy, with things like single flight mutations, I'm happy with mechanisms that can work efficiently for single page apps that are server rendered. I've focused almost my whole self on reactivity. I think signals have seen wide adoption over the last few years, and we're still kind of working on ideas that we've had for a better part of a decade. Solid's reactive system hasn't actually changed very much in almost 5-6 years now, and we're seeing so much innovation happening thanks to Vue, Angular, Preact, kind of coming into the space with us. And I want to take the next step forward. There's a couple topics that I've seen just simply from working on Solid the last several years that haven't really been, nearly as explored as they should be. The first one is async, and the second one is around what I consider mutable reactivity. And these two topics, I think, are really where the game changer happens here, because these are capabilities that we have with these fine-grained signal systems that you don't find in other solutions. Like, we spent so much time, and I'm part of this is like my motivation was to prove what was possible initially. I wanted to show that you could use signals and not lose on, say, the guarantees you have from React in terms of consistency. Like, it was really, really important to me to show how unidirectional flow works, how efficient rendering works. And these concepts React made out there to be important, and they are. This is what, we learned from React. But the thing is, there's more than immutability and unidirectional flow with signals. There's more you can do. And the biggest benefit is how they decouple the components from the state. Like, it's important that you recognize that these things overlap. This is again about recognizing the real answers in the middle. It's not about extremes. If you put all the state outside, like we did with MVC back in the day, there's a lot of duplication, things get clunky, the communication suffers. It's hard. If you put all the state inside the components like React does, there's certain limitations you hit there in terms of locality, things that become blocking, waterfall considerations, all these kind of pieces. The balance has to be found in the middle somewhere. But once you understand that, there's an incredible thing. So like, one of the biggest things that I've been working on is updating async models, which I think is really exciting, because if you look at the mentality around, say, React async, I think they have a lot of the right ideas, things like suspense and transitions. But the challenge there is everything blocks at a component level, because components are what React knows. So on the async side, signals have this real possibility to permeate the whole UI tree without blocking until where they're finally used at the end. You can fetch data at the top of your tree, near the top of your app, wherever you want to, and then pass that data all the way through your UI graph. And it's only where it's read, only where it's used, that needs to actually be blocked. So this innately gets rid of a lot of waterfalls, and it removes the tension people are seeing right now in terms of like passing promises around. Because if you fetch too low in React, everyone knows, then you have this awkward problem of waterfalls, because you block above and you block, and then you fetch, and then you render and fetch, and then you render and fetch and render. If you hoist up the data fetching, well, then you have promises that you have to pass all the way through the tree, essentially. So do you change the API on all your components? Well, it turns out suspense is a read mechanism, not a fetch mechanism. And signals are already a read mechanism. They're a way to read something as deeply as possible. So the same mentality that gives us that fine pinpoint updates and performance in rendering will also give us the ability to eliminate a vast majority of waterfalls inside our components, and do so without necessarily like ripping it all out into a separate tree, actually still co-locating it and getting those benefits. So I think this is a game changer because it addresses not just blocking waterfalls, but it also addresses one of the most painful things that people have who have been adopting signals, which is that TypeScript can't tell if something's nullish from a function call. There's no shared identity. Like if people call a function that may have a value, there's no way when you call the function on the very next line under an if statement that it knows that it definitely has the value. You can't type narrow signals unless you use properties, but then you have a very specific API. And the problem with signals is that they're all just functions. So yes, you can make a specific API, but it's like very clunky. What if, it's so funny because people were always talking about like how this is such a hard challenge, you should change your API. And I think the actual solution is the opposite way. We should just get rid of nulls. So this is kind of the idea, right? Because if your data throws, then it becomes non-nullable. So we have suspense in the data graph without blocking the UI. So very technical, but very cool, groundbreaking kind of thing. And then the other area that I think is really relevant, that's been, I've been looking at a lot recently, is around what we call stores or proxy-based reactivity. We've had this in UI frameworks for like a decade. Vue had their, nested reactive data objects. One of the innovations that we made with Solid was because we didn't have a VDOM, we actually got really good at diffing them to show that we could diff data, deeply nested proxies, and be just as performant as the fastest VDOM, even in situations that were classically not good for signals. What I mean is if the server just smashes you with fresh data for the whole page over and over again, it's a lot easier to diff in those scenarios than it is to you have to do a diff. You have to figure out what's changed and update all the little pieces. Back in the day, people used to just put the whole thing in a single signal, and then guess what? You re-render the whole page. That's terrible. So we did a lot of innovation and research into that, but I realized that this is just at the beginnings of where we're going to go with this. We need ways of deriving mutable data. We need stores that derive stores because there's a superpower here. This is the one place that a compiler can't follow us. I've worked on compilers with Marco. I've looked at Svelte's old compiler with Svelte 3, and I've looked at the React compiler. And the thing that is common in all of these is it's very hard to determine granular updates from a compiler perspective. You can see that something writes, but you don't know all the different places that partial pieces of it are updated to do that full fine-grained update. So the difference between, say, the most optimized React compiled component is if you have a to-do list and you change the checkbox on that one item. This is actually the example that they use. The best you can do with the compiler is go, oh, the list has changed, because I'm assuming you're updating it top level. It's hard to do this without the code in front of me, but generally what it will do is say, oh, the list has changed. It'll rerun the list. It will diff each row. Notice that one row has changed. Rerun the component for that row, diff the changes on all the properties, and then get to that one ID and go, okay, that's the thing that changed. Because the unit of the change is you update the to-dos. You go set to-dos, you spread them, clone them, and then you rerun all the components and even if you're memoized and you're very smart, you go through that step. Whereas when you have fine-grained reactivities, proxies and stores, if you update one property, well, it's only that one effect. It independently updates. So it literally just goes and updates the one checkbox in the DOM. No, the top level component does not rerun. The map function does not rerun. It doesn't diff the difference between each of those items. It doesn't rerun the component that has changed. It doesn't diff the difference between all of those properties, and then goes and finally applies to the DOM. That whole part is missing. And this is the superpower of mutable reactivity versus immutable. With these immutable or compiler-based systems, they have to do all the work. And I think now that that's understood, we need to really showcase this capability. In fact, our Trello demo that we mentioned earlier does an early version of this kind of work, because we were able, again, if you've ever seen a Trello board, you've got a bunch of cards and you're moving around and you're updating them. The standard way you do this with optimistic updates is you render the board, and then, while you move a card, and while it's in flight, you'll merge that card into the current results. So you'll clone the list, and then you'll go, okay, but I'm actually going to move this card over here, and then you put the results out there, and the VDOM re-renders, and then it figures out the differences and updates the DOM. And then if you have 2 or 3 things in flight, like you updated a card and you named it, well, each one of those, as they come in, you then have to go through and clone the list, apply 2 this time, clone the list, apply 3 this time. They lead to full re-renders. You clone all the data. You end up doing this effort over and over again. And what we realized is, by using stores in this situation, and timestamps, we could apply each card change one by one. And if it was a case of something like changing the name, well, guess what? It's a store. So you just change the text. It didn't rerun anything. It just updated the one thing. It's that fine-grained reactivity again on optimistic updates. And then the whole secret was, when the board updated at the end, we then diff against that projected kind of view of the optimistic updates. And if all went well, as in nothing failed, then the optimistic updates should be equal to the fresh data from the server, which means when it diffs, nothing changes. And again, nothing runs. So this is a scenario where using this mutable reactivity with a little bit of diff technology can drastically remove the overhead of these kind of operations. And I know I'm kind of way down on a rabbit hole here, but these are capabilities that you just can't get with coarse-grained or VDOM-like frameworks.
Honestly, my problem right now is that I'm just geeking out too much over everything, and I'm like taking so many notes to kind of go over this. So sorry there, but honestly, I'm really truly enthralled and enjoying this. This is definitely going to be like one of my more favorite episodes that I've had the luxury to be a part of. But thank you. Let's wrap this up. So you can find me anywhere on social media at dthompsondev. I have the same handle everywhere. You can find Ryan Carniato at Ryan Carniato. Is there any other handles that you go by besides that? I think it's just at Ryan Carniato.
Yeah, at Ryan Carniato on X. And then I recently signed up for Blue Sky as well, so you should be able to find me there.
Cool.
And best place though, Discord. That's usually where all the action's happening for Solid. So definitely come out, join the Discord, and get in the conversation.
I'll make sure that we have links to that within our show notes, and as well as if you're watching this on YouTube, in the YouTube description, so that way it'd be easy for everybody to kind of find you there. All right, everybody. This episode today is sponsored by This.Labs, trusted experts in modern web development and consulting. In today's fast-paced tech world, scaling your development teams and bringing innovative ideas to life can be challenging. That's where This.Labs comes in. We specialize in amplifying your technical capabilities, whether it's expanding your dev team with seasoned professionals or streamlining your project's journey from ideation to deployment. Our approach is personalized and collaborative. We take the time to understand your unique business needs and craft tailored solutions that not only meet but exceed your expectations. With a proven track record of driving innovation and delivering results, we empower businesses to stay ahead of the curve and maximize their ROI. Visit this.co, that is THISDOT.co, to discover how This.Labs can help transform your vision into reality. Big thank you to This.Labs for sponsoring this episode and their unwavering commitment to advancing the developer community. And that's today's episode, everybody, and we'll see you on the next one. Bye.